All right, welcome wonderful people. So today we are going to be using strategies to solve quadratic word problems. So steps for solving quadratic, well actually this goes for any kind of word problems because I always get every class, semester, students that always say, I'm good at math, but I'm not good at word problems. Well, where are you going to use math in real life that has nice little equations? The truth is, if you want to use math in the real world, you got to know where to look. And you also have to know strategies for solving those problems. The first one is to familiarize what is being asked. All right, so what do they want? What do we have to do to answer the question? The next step would be to translate it. So assign values and variables. So we have to basically make an equation, and this can be very simple at times. You know, I mean, if I could probably come up with a very simple word problem, and without even thinking about it, you already know what kind of operation that you would need to do. And, you know, you'd be able to answer the question pretty quickly. And then you have to solve it. So find the value of the variable. So basically you do algebra stuff if you need to, and make sure that it works out. To make sure it works out, you have to check it. Now, when it comes to word problems, it helps to know a little bit of background information about what you are solving for, okay? So if I asked you, being high schoolers, let's say we solve a problem and we get something like 900 miles out of a tank of gas. All right, and then we do our math stuff, and it turns out we get 41 miles per gallon. So in that case, well, it depends on what kind of car it is. If it's a motorcycle, maybe a hybrid, but for most cars, 41 miles per gallon is unrealistic. It doesn't make sense. So I oftentimes call this the sniff test. The other way you could check it is to plug it back in and see if your equation balances out. And lastly, state your answer in given units. Now, in this case, we're talking about familiarizing. When most students get stuck on a word problem, the step they most often get stuck at is going to be familiarization because they're unfamiliar with it. So what are some things you can do to help you understand what kind of problem you're looking at? First thing you could try is to draw a picture, a diagram, or a graph. A lot of times word problems require more than what is in the statement to figure out. Okay, so maybe you're not working on something that requires a picture or even just to understand it. So another thing you could do is make a list of what you are trying to find. So every single word problem gives you enough information to solve the problem they're asking for. So there's usually a path to get from what they give you to how you are supposed to answer it. So the other thing is, what clues do they give you? Now this is for just any word problem in general, right? So we may not use all of these strategies today, but there's always some kind of clue that you have, all right? And these clues are not numbers usually, all right? So there are operators, there are word problems, what we call keywords that we would use. You can also estimate to get an idea, and this works well with things like fractions, where fractions are very intimidating. When you see them, you're not sure what to even do. So what you can do is round it to the nearest whole number and see what kind of answer you are supposed to get, and kind of work backwards from there to find out what operation you need to carry out. And lastly, you can underline those keywords. And there's other kinds of clues besides keywords, but let me go ahead and give you a short list of keywords that you could use. All right, you might want to take a picture, screenshot this, because it's going to be a while if I have you copy it. But don't worry about it. I'll have these posted somewhere so that you can get them at any time. Now, again, I'm not sure exactly which of these we're going to need today, so it pays to just sort of know a few of them. In fact, most of these are, you've seen these before or are pretty familiar. Usually the ones I have to I kind of have to draw attention to is less than, and let's see, what was the other one? I know it was another, but I think less than was probably the one that everybody messes up, because that one is backwards from the way you might think it goes. But otherwise, all of them are pretty straightforward. All right, so let's go ahead and begin the exercises. So the width of a rectangle is 6 meters less than its length. If the area of the rectangle is 112 meters square, find the dimensions of the rectangle. All right, so this is one of those ones that we have to be familiar with. So in order to familiarize ourselves, we're going to need a shape. Now, it calls it a rectangle, and we don't need to be artists, okay? We don't need to have an advanced art degree, or we don't need to have years of practicing drawing anime characters in order to get this, okay? Drawing a rectangle or a diagram is as simple as just doing this, okay? So the width, so this is the width of the rectangle, and it is 6 meters less than its length. So there we go, there's our first tricky one, the less than. This is not the mouth that wants to eat the bigger number. This type of less than is a different kind of less than. If I said that your younger brother has 2 years less than you, that means it's a subtraction problem. So 6 less than the length. So here's the length, and we have 6 less than. So there is the first type of question. But let's go ahead and rename this. Well, actually, I'll leave it. We don't need the W anymore, because now we know that this is the W. Width is 6 less than the length. And it doesn't say anything about where the length is, so we don't know what the length is. So we'll just go ahead and give it L. We don't know what the length is, but the width is 6 meters shorter, or 6 meters less than the length. And we also know that these two, it says the area. So the other clue is the area. So this means that we would need an area formula. Area is length times width. So this is a multiplication problem. And let me go ahead and just put that here. Area is equal to 112. Well, it's meters squared, but that's okay. We're not really worried about the square right now. So this means we need to multiply both of these together. So length times length minus 6 equals 112. There we go. So what could the dimensions of the rectangle be? Because that's the other thing. Every word problem has the question statement. Usually it's the last one. And that is, in this case, they want us to find the dimensions of the rectangle. So with this here, it doesn't really seem like there's much we can do, right? Well, we got to use our quadratics in this case. So actually, let's see, L times L. So I'm going to go ahead and multiply length times length, and we get L squared. Multiply here, so minus 6L. And I want to put everything on one side. So I want everything on one side, so that means I'm going to minus 112 from both sides. And this is something we've been working on all this time. We've been working on putting things in the correct order so that they can be solved with whatever equation we're looking for, whatever method. So we have a couple of methods. Remember, we already reviewed some of those. And some of those methods were, let me see if I can find a really good list of them because they're still here. So we have factoring, square roots, completing the square, and quadratic formula. So those are some of the ways that we can solve this. All right, so let's go ahead and look at this, and let's think of two numbers that we could multiply to 112, but we'll have a difference of 6. And I think that this one can be done pretty easily using factoring. So 112. So if you're not sure, you can always multiply using a factor, either a factor tree, or in this case, I'm going to use a factor list. So 1 times 112, 2 times, and let's see, that would be 56. And this is going to probably be a while, so let's try, let's skip a few and try to go to 6. So 6 times what would give me 112? Which I don't think, no, 6 is not going to work. So let's go ahead and try something else. Let's go with 8. So 112 divided by 8 is going to be 14. All right, there we go. This is probably what we were looking for because 8 times 14 is 112, but they also have a difference of 6. So let's go ahead and use our method for factoring. So the last numbers we have available to us are going to be 112. So 8 and 14 are going to be the two numbers that we would multiply to get there. Now remember that this means they are going to be different because the only way to get a negative number by multiplying, so again, positive times positive is positive, negative times negative is also positive. The only possible way we could get a negative number is if one is negative and the other is positive. That's the only way to get a negative number from two factors, from two numbers being multiplied. So now this means one is positive and the other is negative, but again, that means they are going to be different. So which one is negative and which one is positive? So if we made 14 positive, that would be 14 minus 8, which would be positive 6, not negative 6. So another indicator you have is your first sign is going to be the larger number. I say larger, not greater. So in this case, 8 minus 14 is negative 6. So this works out. Now, just to make things a little bit easier, I'm going to switch L to X, which I'm going to probably do from now on. I'm probably going to convert all of the numbers to X because it just fits better from what we've been doing with quadratics. All right, so now I'm going to go ahead and use my zero product property. So X minus, well, oh, hold on a minute. Let me do one step at a time. All right, so minus 8 from both sides. And over here, to get rid of this 4, I'm going to add 14 to both sides. I meant to say 14. Okay, so this means that we have two possible lengths. So one length is negative 8, and the other length is 14. Now, if you remember what I said earlier, let's see, where did I put that? Does it make sense? Does this make sense? Is it possible to have a rectangle with a width of -8 meters? No, because distance can never be negative. This is an extraneous solution. We made no errors in the math. The math is good. We followed what we are supposed to do. But just because of the way things work out, it, well, doesn't work out, because you cannot have a -8 width. So this means that the length must be 14. Now this is not our answer yet. So let's go ahead and type out the answer. So the length, length is 6 less than, okay, so we need 14, the width. Okay, so we know the length is 14 and the width is 6 less than. So let's lessen this number by 6. So that would be 8. Now, not exactly the same 8 as this one here, all right? Not the same one. Somehow this just worked out as a coincidence that it was going to work out this way. So there we go. That's the first problem. And we should probably check this really quick by plugging it back in. So if I multiply, let's go ahead and multiply 14 times 8, which actually we already know that's going to work because that was our set of factors. So 14 times 8 is 112. So that means that this is indeed going to work out by plugging it back in. So again, we checked it, we looked at our answers, we threw out the ones that didn't make sense, and we plugged it back in. We also drew a diagram and assigned variables to an equation. So we used pretty much most of our strategies. All right, so another rectangle type question. So this rectangle is 1 foot more than twice the width. So let's see, if I were to pick it here, this would be a perfect square, but it's a little bit more than twice the length. So there we go. If the area of the rectangle is 300 feet, so there we go, we have another rectangle that is 300 feet area. Find the dimensions of the rectangle. So length is 1 foot more. So one of these has to be the starting point. So we have length and width. Length of a rectangle is 1 foot more than twice its width. So in this case, they give us a clue to the length, which is the longer side here. So 1 more than twice the width. So in this case, we are comparing both sides to the width. So I'm going to go ahead and assign the variable. So the length is, in this case, it is, well, I'm going to write this a little bit more conventional, what we would expect it to look like. So the width, I'm going to just reverse it. So instead of 1 plus 2w, it's going to be, I'm also going to convert it to x as well. And w is now x. So we assigned our variables and values. Now, the next thing we need to do is start working on this. So it is another multiplication problem. So it is length times width or width times length, because multiplication works both ways. So x and 2x plus 1 equals 300. So this has to come out to 300 somehow. All right, so let's go ahead and do this. I think this problem is going to be very similar to the other one that we just got done working on. And let's go ahead and multiply this out. So x times 2x is 2x squared. Multiply this out, so we get 1 times x, which 1 times anything is going to be that same number. And I'm also going to minus 300 from both sides because I want this number to be, I want this whole thing to be equal to 0 so that we can use zero product property. Now you can use any of the techniques that you were shown. So if you, well, I don't think completing the square is going to work on this one. Actually, no, it might. Solving by square roots will probably not work out on this one. Quadratic formula will definitely work out on this, but you might end up with some strange answers and it will take a little bit longer. But I'm also thinking that we could use factoring again. And also this seems like a pretty good opportunity to use the factoring that was shown earlier, that what we call the AC method. So take your A value and multiply it times your C value. So we're going to end up with a separate kind of equation. So we have x squared plus x minus 600 equals 0. Now remember, we just sort of borrow this. This number here is borrowing the 2. At some point, we will have to put it back. So let's go ahead and factor this. So I need 2 numbers that multiply to 600, but have a difference of 1. So let's go ahead and go back to the calculator. And let's go ahead and go 600 divided by 20. All right, so 20 times 30 will make 600, but they have a difference of 10. So let's try a different number. Let's try 600 divided by 23. In this case, we get an irrational number, or at least a repeating number. That's a very long repeat, actually. I must save this for future use. Anyway, 600 divided by 24. In this case here, 24 times 25 is equal to 600. So it has a difference of 1 as well. So this is the combination we are looking for. Now again, when you have a negative here, that means you are going to have different signs. So one is going to be positive, the other is going to be negative. Now, which one is 24 and which one is 25? So 25 is the larger one because your middle number must add up to a positive number, which means this is going to be the negative value. I'm going to put x and x in here. And remember how I said that we will have to give back the number? So we are going to have to give back the 2 that we borrowed. And it might seem like it's pretty tough to do it this way, but it's actually way easier because if I were trying to use factoring the normal way, all right, so I'm going to go ahead and divide 25 by 2, and that would be 12.5. But it's going to be minus because if I solve it, I'm going to have to minus 12.5 from both sides to get x by itself. So x is equal to negative 12.5. And here I would take 24 divided by 2, that would be 12, just 12 as a regular number, and then add 12 to both sides. So I have 12 on both sides. Now, similar to the last one, we have an extraneous solution because we cannot have a negative distance. Negative distance is just something that doesn't happen. So this leaves us with only one possible solution, and that is 12. Now, if we know that W is equal to 12, what does that tell us about the length? Well, let's go ahead and plug in 12 in for W because now we know W is 12. 2 times 12 is 24. 24 plus 1 is 25. Okay, so we know the length is 25 and the width is 12. And we could check this really quickly by using our calculator. So let's go 12 times 25. Oh, looks like we already have 25 there. 12 times 25 or 25 times 12 is 300. So this answer checks out. So this is very likely the correct solution to this problem. Now, again, you might be thinking, well, is this 25 the same as this 25? No, it's not. Okay, so don't get into this belief that you can look for shortcuts because in this case, this is another coincidence. But that's kind of the way math works out. You know, if you're talking about the same thing, you know, the same operation on the same problem, you will oftentimes get repeating numbers that sort of pop up back and forth. So, but not all the time. It's not good enough to where you can make a shortcut out of it. Anyway, there we go. Another problem down. I think this one has about 10 problems. I'm not sure how long this is going to last, but we'll keep going. Okay, let's see here. The dimensions of a rectangle can be expressed as x plus 6 and x minus 2. If the area of the rectangle is 65 inches squared, find the dimensions of the rectangle. So it looks like we have another rectangle, and again, it doesn't need to be the best rectangle ever, okay? It just needs to be enough to where you can get this idea. Now, we don't know which of these is going to be the longer side or the shorter side, and in fact, I'm thinking it may not even really matter all that much. So let's go ahead and just multiply them out because in this case here, we're not looking for which one is the shorter side, the longer side, or anything like that. So I'm thinking that we could easily just sort of fit this in, work it out, see what happens. All right, so let's go ahead and use FOIL. So first numbers, x times x is x squared. Outside number is negative 2x, and inside number is plus 6x because 6 times x. Don't forget to watch for the signs. So if there's a negative, it's going to be a negative number. 6x. And last number, so this is negative times positive, which is negative. 6 times 2 is 12. So also I'm going to minus 65 from both sides. So I get 12 minus 65, and that will leave us with 0 on this side here. Now, let's try to move everything to one side so that we can use our zero product property. Oh, we'll need to combine these two here. So let's see. 12, I'm sorry, 6 minus 2. 6 minus 2 is 4x. So let's put 4x here. Combine these two because they're also like terms, and that would be negative 77 equals 0. Not too bad. Now, can we factor this? And I like to factor things as much as I can. So factoring is usually one of the faster ways to do this with the least amount of writing. So let's go ahead and try factoring. Are there two numbers that I can multiply to get 77 and have a difference of 4? Chances are you're probably thinking of the same thing I'm thinking of. So if I ask any student randomly, think of two numbers that multiply to 77. They're going to say, anytime something with 2 digits comes up, they're going to say, well, how about 11 times one of those numbers? One of the digits of 77 is 7. So that would be 7 times 11 is 77. And they also have a difference of 4. So in this case, factoring will work out. X squared And let's see, we're gonna, oh, nope, 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 we're gonna have to factor this out. So, well, we could use X, but I'm gonna do things that are the normal way I've been doing this. All right, so again, we have a clue here, and that is one is going to be positive and the other is going to be negative. So again, 7 and 11 go in here, but which one goes where? Because if I put 11 here and 7 here, that would make this middle number a positive for X. So we know that, again, if it's a negative, that's where the larger number goes. And let's get our first numbers in there. So we took care of the add and the multiply here. And we could solve each of these. So X plus 7 equals 0. And X minus 11 equals 0. And I'm going to have to, let's see, minus both sides, minus 7 on both sides here. And over here, I'm going to have to add 11 to both sides here. So X equals, and we have two possible answers, two possible solutions, I should say. And that is -7 and +11. Now again, we got to give this the sniff test. You cannot have a rectangle with -7 units, or in this case, 7 inches. So that means that we have, let's see, dimensions. Ooh. Okay, so one of these is going to be 11. But what's the other one going to be? All right, so let's go ahead and plug 11 into one of the originals. So 11 plus 6. 11 plus 6 would be 17. Now let's go to the calculator and see if this makes sense. So 11 times 17. In this case, we get 187. So the area is not 187, it is 65. So 17 is not going to work out. So let's try the other option, 11 in this one here. So 11 minus 2 is 9. So let's see. In fact, you know what? I don't think this one's going to work either because that would be 99. So we've made an error somewhere. And I think I found it right here. 6 minus 2 would be +4. Okay, so if your tire goes out on your car, you don't throw out the whole car. Let's see what we can save. So in this case here, all that would happen is these would switch signs. So that would make this one a positive. And let's see, that would mean that this would have to be plus, and these ones would be minus. So minus, minus. And these would be positive 11s, which would make actually 11 the extraneous one. So in this case here, -11 and 7. All right, so let's try 7 then. 7 plus 6 is 13. So let's try 7 times 13. If 7 times 13 equals 65, then we know that's going to be our right combination. So 7 times 13 is 91. Okay, so maybe not 7 and 13. Okay, let's see. Plug it back in. So, oh wait, maybe it's not 7. So let's plug 7 into 1, and we get 7 plus 13. And if we plug 7 into the other one, we get 7 minus 2, which is 5. and 5 times 13 might work out. So in fact, in this case, we use 7 nowhere in our answer. Sometimes it's like that. Sometimes you will get the answer from the math and it will be neither of those things. So this works out 5 and 13. Dimensions. And let me go ahead and put the units in there. I think I have been fairly bad about that on the last problems. Okay. Let's move on here. Okay, let's see. This is the 4th problem, and I'm not sure how long this has gone on for, but judging by the time, I think we may have to break this into 2 parts. Because, well, hold on a minute. The base of the triangle is 7 less than twice its height. The area of the triangle is 102 centimeters. Find the base. Okay, so let's see. Well, we could draw a figure. I don't know if this is going to help. So let's see, the base of a triangle is 7 less than twice the height. 7 less, and there is that less than, the tricky one again. That is easily the trickiest type of word problem keyword that you will encounter. Because if students do this on their own, it's going to look something like this: 7 less than twice the height. Which I'm going to tell you, that's not going to work out, because less than is backwards than you might think. Again, I gave you the example of, you know, your cousin is 2 less years than you. So that is going to be backwards. So 2h minus, oh, it says 7. 7 less. There we go. And it does not give us any clue about the height. So we're going to call x the height. And since this is comparing it to the height, I'm going to take out the h and replace it with x, because we are going to have to do some quadratic stuff with it. Now, in this case here, we are going to need to be familiar with the area of a triangle. And this is one of those that I always get. I always get students that will constantly get this wrong because they will just multiply it together. It will look something like x, 2x minus 7 equals 102. Now, if we did this, this would be wrong, because this is the formula for a rectangle or a square or any other type of quadrilateral figure with parallel sides. And this is one of those things that you shouldn't have to, you know, like I get students that say, I don't know the area of a triangle. Well, look it up. There we go. Area of a triangle is base times height divided by 2. base times height divided by 2. But there's also another one, and that is the area is half of base times height, or again, base times height divided by 2. So there are two of them that it looks like we could use, and this one here looks like it's the other one, half of base times height. So as I always tell students, the internet is far more than just looking at funny videos. All right, it is an educational tool. You have all of human knowledge at your fingertips, so it should be fairly easy for you to just look up something that you don't know. All right, so there we go. We just need to put half of base times height, or height times base. In this case, it wouldn't really matter. Whichever way is better to multiply or whatever. Okay, so let's go ahead and multiply this out. So 1/2 of base times height, so this would be 2x squared minus, and then 7x. Oopsie, almost forgot this side of the parenthesis. So now we have to, actually in this case, I think I would probably still, how can we get rid of this half? I mean, I could multiply both sides by half, but then that would be a problem because we cannot take half of 7. But what we could do is use some basic rules of algebra. I could times 2 to both sides. So times 2 here, times 2 there. So remember, in algebra, you can always do something to both sides and it still is going to be equal. So by taking 2 times 1/2, that's going to cancel out. 2x squared minus 7x equals 204. Okay, now if I minus 204 from both sides, I end up with negative 204 on this side. And I'm going to go ahead and set it equal to 0. Now I did that just to save myself some space because I feel like I might run out of space. Okay, now again, factoring is pretty tough, especially when you have a number in your a value other than 1. So let's go ahead and use our AC method. So multiply 2 times, again, you can also use solve by trial, okay? You can use solve by trial, which means you basically try different things until it works. Which if I had more time, I would probably do a few problems like that, but I'm gonna try to keep this nice and short if I can. But you would just put like just an example, you would probably put something like 2x, if I'm trying to solve it from here, they might be different. So 2x plus and minus. And then I'd have to find numbers for here and then try it out. You know, I'd try different numbers and see if it works out. Anyway, so let's go ahead and get back to trying to solve it using our regular methods. And we're trying to get two numbers that multiply to 408, but have a difference of 7. So 208 divided by, let's go ahead and divide this by 15. All right, 13 and 15, not gonna work. 13 times 15 is not gonna be 208. So 208 divided by, let's see, we tried 15. Let's try 16. 16 and 13. 16 times 13 is going to work. But they don't have a difference of 7, they have a difference of 3. So we're very close. 208 divided by 17. I said divided. oh wait, I'm sorry, that's 408. 408 divided by 15. Okay, that's not going to work. 408 divided by 16. All right, let's see. They have a difference of 5, 9. Okay, so 9 is, they have a difference of 9. So we might actually be very close. 408 divided by 17, that is 24. Does that have a difference of 7? Let's see, 24. Oh, they do. Okay. I don't know. I'm just spacing out here now. It's okay. It happens to all of us. All right. So there we go. We know what the numbers are. So I'm going to go ahead and start factoring that. All right. So we have x minus 24 and x plus 7. All right, so again, bigger number is paired with the negative. So 17 minus 24 is negative 7. And again, one has to be negative and the other has to be positive because they multiply to make a negative number. And the only way you can do that is if one is positive and the other is negative. All right, now, because we use the AC method means if we take 2, we're going to have to put it back. So this means that our x value could be one of 2 possibilities. It could be, let's see, it would be opposite of this one here. So 24 divided by 12, 24 divided by 2 is 12. And again, it's going to be the opposite because I'm going to have to add 12 to both sides to get rid of it. And we could also say, in this case here, 17 divided by 2, that would be negative 8. Oh, is it negative 8.5? I think it is negative 8.5. Let's see, 8 plus 8 is 16. Yeah, okay. Now again, we run into another problem of extraneous solution, and that is we cannot have a negative result. So we have one possibility, and that is 12, but this is not the, this may or may not be what we're looking for, because if we read the question, it says to find the length of the base. So that means we're looking for this number. So we're going to have to do the same thing we did with the last problem and check it to see if it will work out. So, oh, actually, hold on. This is the height, not the base. So that would mean that if this was 12, what would this be? So 12 times 2 is 24, and 24 minus 7 is going to be, wait, 24 minus 7? I don't know, but 24 minus 7, and that will be 17. So that means this would be 17. So 17 times 12. Now, it should come out to 102. 17 times 12. Okay, let's see. Oh, you know what? The area of a triangle is supposed to have half. So 1/2 times base times height. So we almost forgot one important step, and that is to multiply it by half. 204 divided by half is 102. So it does come out to 102, so that means that it's 17 and 12 are what we're looking for. But in this case, the question is telling us to find the base. So the base is, let's see, 17. And let's go ahead and put our units in there. So 17 centimeters. Okay. Now, because these are fairly long, I'm going to go ahead and make this the last problem for today. We'll go ahead and call it after this. We'll do half today and half tomorrow. All right, so with this one here, this one would be number 5. The hypotenuse of a triangle is 1 foot more than twice the length of the shorter leg. The longer leg is 7 feet longer than the shorter leg. Find the dimensions of the triangle. Whew, okay. Yep, that one was a doozy, just reading it. All right, but let's go ahead and fill this out. So what we know that when something mentions hypotenuse, that means it is a right triangle. Because in a right triangle, the side opposite of the 90-degree angle is the hypotenuse. So it says 1 foot more than twice the length of the shorter leg. And we'll go ahead and call this X. I don't know if this is, we might have to adjust this or not. And there are 2 legs, the short leg and the longer leg. So this third side here is the longer leg. It says the longer leg is 7 feet longer than the shorter leg. So in this case here, 7 feet longer would mean that it is plus 7. All right, let me just check this over one more time. Twice the length of the shorter leg, 1 foot more than twice. Longer leg is 7 feet longer. Find the dimensions of the triangle. Okay, so we want to find all 3 sides, the length of all 3 sides. All right, so how could we do this? Now, with a problem like this, we do have a couple of options. We could also, well, in this case, we're going to have to be familiar with something. And I'm trying to think of how the best way I could have you remember this would be. But we would need Pythagorean theorem. And that is a square plus b square equals c square. And that means, again, short leg, long leg, square them both, and that will equal to the hypotenuse, or the longest side, also squared. So you got to remember, whenever you use this, you got to put this as your longest side. All right, so let's go ahead and try this out. So x squared plus b squared. So that means, again, it's not the longest side. You got to make sure to put these in the right place. So that would be x squared plus 7. And this has to be squared as well. Equals to, now all these are kind of together. And since they're all grouped together, we have to square them together. So this looks like it's going to be quite a bit of work to get all this put together. So let's go ahead and multiply all of this. So x squared plus, now in this case here, it would be, oops, why did I put a square here? I don't think I needed to put a square there. I knew I was going to put a square there. But actually, there is no square there, because here, if I look at my diagram, there is no square. So that's another reason why it's a good idea to have a diagram, so you can follow your work. All right, so I kind of knew this, and I was getting ahead of myself. X times x is x squared. Now, I'm just going to have to use my imagination and imagine there's another x plus 7 over here. So that would be plus 7x, And my inside would be 7 times x. So that would also be, so that'd be 7x plus 7x equals. And if you want to write this whole thing out, that's fine. You know, I mean, I would actually recommend that. So 2x times 2x is 4x. And let's see, this would be 2x, 2x times 1, so that would be 2x. And let's see, inside number would also be 2x. And last times last, so last number times last number is 1. Okay, now, oh shoot, you know what? I almost made a big mistake. I forgot to put a 49 in here. Oops, I can't seem to move this out of the way, so I'm gonna put 49 right here because there's supposed to be a 49 because I forgot to multiply the last 2 numbers here. So now let's go ahead and try to combine everything. So this would be 2x squared plus 14x plus 49 equals, and here I'm going to go ahead and put this together. That should be a square. 4x squared plus 4x plus 1. Now I need to move everything to one side. And if I were to move them to this side, I'd have to minus 4x squared, which would make this a negative. But we don't want negatives on the a value. We don't want to start it out with a negative. So that means I'm going to have to move everything to this side. So minus 2x squared from both sides. I'm also going to have to minus 14x from both sides. And I'm going to have to minus 49 from both sides. So here we go, 2x squared, because I'm adding these two together. 4 minus 14 is going to be negative 10x. And let's see, 49 plus 1 is going to be negative 48. All equal to 0. And I don't know if we can factor this one out. I'm always kind of worried because I'm always afraid that I won't be able to factor some of these out. But let's give it a shot. So, oh man, I'm also going to need to do one other thing really quick. To find out if I can factor it, I'm going to need to use the AC method. So that means take my 2 and multiply it times here. So that would be 80, no wait, 48, 96, I think. Let's see. 2 times negative 48. Oh, you know what? Maybe I don't need to do that. We could try something else instead. Because we don't want this a value in front of this number rather than doing that, which actually that will work out, but I just thought of an easier method. Why don't we divide everything by 2? Because these are all even numbers, I can reduce them. And I don't have to do any other methods. I don't have to like divide both sides by 2 and then times both sides by 2 again or something like that. Or actually it would be the backwards of that. It would be times both sides by 2, then divide by 2. But if you can reduce your entire formula, that would probably be a much better option. All right, so now I need to think of 2 numbers that will multiply to 24. And one is going to be positive, the other is going to be negative. So what 2 numbers can I multiply to get 24 that have a difference of 5? So 24 divided by 6. Okay, maybe not. It has to have a difference of 5. So 24 divided by 8. And 8 and 3 have a difference of 5. So that means that 8 is probably what we are looking for. So 8 is the negative because that is the bigger side. And this is going to be 5. And now we should have enough to solve it. So x equals -5 and +8. Now, again, we do run into this problem of extraneous solutions because it cannot, 5, where the heck did I get 5 from? It would be 3 because 3 times 8. But again, that wouldn't work out either way. We can't have -3 because that is, it's just not going to work. We can't have a negative number. All right, so it says to find the dimensions. So for this one, I'm going to draw another triangle that kind of matches the original. And we know that the shortest leg, x, is 8. We know that this here is going to be 8 plus 7, which 8 plus 7 is going to be, I feel like I should have a calculator to double check myself here. That would be 15. And now let's go ahead and try to find the last one. So x is equal to 2x, so that'd be 2 times 8, which would be 16 plus 1, which is 17. So let's go ahead and put our answer together, and that would be, let's see. I mean, we could probably just put this as our answer as well, this triangle that we drew. But we could probably also do something like this. The short leg is 8. The long leg is 15. And the hypotenuse, which we'll just use h, is 17. And it does not give any, I don't think it gives any dimensions. So it does not say whether it is feet or inches or anything like that. So that probably means that we don't really need to put a unit in there. So we are probably done with this problem here. All right, I guess that that would just about be it. That is it for today, and thank you for showing up, and I will see you next time.